Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to do a walkthrough of QuickSurface LITE. We're going to talk about the general process, the tools we have access to, and maybe where QuickSurface LITE falls short and you may need the Pro version. So we are going to be using a file from the examples called basic part, but I do want to highlight a couple of tools that the basic parts don't really show us. So what we're going to be doing is we're going to focus on first editing or manipulating the scan data, and then we'll get into extracting primitives, aligning it, and getting 2D sketches and actually building some shapes in 3D. So the first thing to note is when we start this process, the first step is generally going to be cleaning up the mesh. Now, depending on the mesh that you have, you may or may not even need to do this. So this mesh is the stator cover from one of my KTMs. We've taken a look at this with the Metro X. But what we have here is a couple of holes, areas that just got filtered out when processing this with RevoScan. So what we're going to do first is select Edit Scan, which can be found on the main tool tab or under Scan Data. Select Edit, and we can see here that it has individual meshes, 1, which is good, and then we have holes, 22. Now what we see with this is we want to select Edit, and then we can pick the holes, and we can use the option to fill the selected hole. Now, this is not going to be a perfect solution for every situation, but this helps us clean up the mesh a little bit, allowing us to select areas where there may be a hole in the mesh and fill that data in if we need to get something like a 2D mesh section sketch from an area where there's a hole. Now, once again, it's not going to be perfect. It does rely heavily on the surrounding data that's available for those areas. So if you have a hole that traverses past or over a corner, you may find that filling that hole in just isn't really going to give you a good result. But in most cases, I found that these holes end up in certain areas like deep pockets where we just couldn't scan. And if those areas are more planar in nature, then it'll do a really good job of filling that in. There are some other options that we're not going to go into, but fill semi-holes, and we've also got this bridge option. And I'm going to select back. And we do also have a couple of selections up here. So we've got a magic wand and a paintbrush and things like that. Again, not really what we're going to worry about here. The main thing I wanted to show was filling in those holes, because that's a common problem that we have when we go from our scan data, because sometimes if we don't capture enough points in a certain area, when it goes through the process of turning it into a mesh, we end up with those holes, and it's kind of too late. We need to fix them either in RevoScan or the Creality scan software, or whatever scanner you're using, and then we need to go into another piece of software like this, QuickSurface LITE. Another thing that we might want to do is talk about reducing the number of polygons and reducing the noise in our scan. Now, the number of polygons here can be important to the performance. So if you find that you're actually having trouble and the performance is a bit sluggish, then maybe reducing the number of polygons can be a good way to sort of handle this. We can see here that the current number of triangles is 357,000. This is actually a version of the scan that I've already reduced, so I don't really want to take it down anymore. You can see here, these were actually scratches from a crash on this cover, and those are kind of sort of melted and faded away. So it doesn't have the resolution that we had on the original scan, which had millions of triangles. But the other thing we may want to do is reduce the noise. Now, reducing the noise, this is a way for us to take sort of a scan that has an orange peel effect, and we can reduce the noise by allowing it to go through a number of iterations. And again, it's going to be raising up certain points and lowering certain points. And using this process to smooth out a scan with this, 1 to 5 iterations is a great way to take care of this before you get into reverse engineering it. So now that we've taken a look at just a couple of those basic scan data tools, I'm going to hop over to the Help menu under Examples and select the basic part. Now, the basic part, this part is not aligned to a coordinate system. You can see that there are some sort of jagged sections on the edges, not something we're really concerned about right now. We've got this little slot feature, which is off axis. It's not aligned, or it's not normal to the middle of this part. And this part is not truly cut in half. This is not a half section. So there are a couple of things that we need to deal with when we're talking about getting this part ready to 3D model. So the first thing that we want to do is extract primitives. The primitives are going to be used to align to a coordinate system. We can also use these primitive tools downstream for things like cut surfaces if we want. If we happen to be exporting solid and surface models, we can take these along with them. But for right now, the first thing that I want to do is I'm going to create a midplane, and I'm going to use my magic wand tool and just select this face. And you can see that it does a pretty good job of highlighting most of the face based on the triangle angles. We're going to select fit plane, turn on the analysis option. You can see that it's all green, which is good. And we're going to select create and stay. The next thing that I want to do is rotate this around, and I want to create a plane on the bottom. Once again, I'm going to select plane. It's all green because the analysis tool is still on. We're going to create and stay. So now I have a reference for the bottom of my part. I have a reference for the middle of my part, but I also need a reference for where the center of my coordinate system is going to be. Now, for that, we also need to think about the orientation of our coordinate system. The center of the coordinate system can take care of itself based on this plane selection and this plane. So plane 1 and plane 2 will automatically align it, but to center it, we also may want a cylinder. So what I'm going to do is select the inside here, select cylinder, and we can see that there's this band in the middle where it's a little bit away from being a good fit. Most of it's blue and green, the middle section is red, but I'm okay with that. So I'm going to select create and stay. The last thing that I want to do is I want a reference for this face here. So when I go to reverse engineer this, I want to know exactly where that feature is. You can see that it's kind of messy. We're not going to get a good reference from that, but for right now, we at least want to know where that face is, and we're going to select create. So now we've got a couple of planes, we've got a cylinder, and all of these can be used for our alignment. We can see in the upper right that our alignment here is not really aligned to a coordinate system. And if we go to edit view and we turn on our coordinate system, you get an idea of how far away it is from the origin. So we now want to use the align by coordinate system. The first thing that we're going to do is use this drop down. We're going to select plane 1. So this is going to put our XY plane on that plane with Z pointing away. If we need to flip this, we can use the flip option if we want Z pointing a different direction. But this isn't going to dictate the direction of Z pointing up, how we would want this if we were to model it. Next, what we're going to do is we're going to select our second reference. And this can be picked on the screen, but in this case, what I want to do is select plane 2. This is going to automatically put our coordinate system down at the bottom. And you can now see that Z is pointing away, X is to the left, Y is down. We can flip this and have Y pointing up. But again, Z is not in the correct orientation, not really a big deal. But what we may want to do is flip these options around up top for our primary feature until we've got Z pointing the direction that we want. And then we can use the flip options to make sure that Z is pointing up and X is pointing to the right if that's the coordinate system orientation that we need. And last, we may want another reference. It actually looks pretty good, so I don't think I even need a third reference. But if you did need a third reference, again, you could pick it off the screen by using this drop-down or just by using this pick option. For example, if we wanted to use the cylinder. Now, the problem with that is the cylinder, again, is not centered, so it's not going to really add anything to us. But note that it does give us some options for how we would define the X, Y, or Z axes. So everything here looks okay. The last thing that we want to make sure we do is apply on all features, which means all of our primitives, our planes and cylinders are also going to move with the mesh file so that everything aligns to the coordinate system. And now we can close this. So now you can see our part, all of our planes, everything moved to the coordinate system for us. Now at this stage, we could simply go to export. And we could send this as a mesh file, or if we want to export the primitives, we could export those. And we could bring it into another program like Fusion if we wanted to use Fusion to reverse engineer this based on mesh section sketches. But if you want to stick with QuickSurface LITE, let's talk about where the limits are of the program. So the first thing that we would do is select 2D sketch. It's going to automatically grab what they call the OXY. So O is the origin and XY plane is our bottom plane because of our Z orientation. And what we would likely want to do is pull this up until we have a good reference. And once we have a good reference, we can select create or we can select create and stay. But in this case, what I'm going to do is select create. This is going to bring me to my edit sketch, so it automatically goes in and starts editing for us. And then from here, we could start to create these shapes like lines or polylines or rectangles or circles, or we can use the tools to extract primitives. From here, I want to use extract primitives because this is actually a really good way for us to define this. I'm going to start with fit circle, and notice that instant fit is turned on. We can hold shift to temporarily disable that if we want. But what we need to do is simply take our cursor, hold down the left mouse button, and drag over these sections. And notice that this is automatically fitting a circle for us. Now, one thing that happened here is I'm going to actually go and hit back, and I'm going to select these and delete them. But one thing that happened is when we let go of the cursor to come over to this side, it started to create a second version of that. So let's go ahead and delete this one, go back and do extract primitives. So what we're going to do is we're going to hold down the shift key. This is going to let us jump over and come over to here, and then I can let go of the shift key. And now it's going to take into account all of the mesh sections that I selected on the left side of that slot and everything on the right side. So again, this is all based on instant fit. So you can turn this off by checking this box, or you can hold down shift to temporarily disable it. Next, what we're going to do is select the fit line, and I'm just going to draw it across here. This is going to give me a line, and then we can select back. Now, once we're here at this stage, we may want to hide some of the planes and cylinders just to make this a little bit easier. Now, this line doesn't extend all of the way. So what we want to do is use this modify option and just manually drag it until it snaps. When we're in 2D mode like this, the middle mouse button isn't orbit anymore. So this allows us to simply just use it as a pan option, which is pretty nice. And now that we've got this, we can use the trim tool. And we're just going to drag through, and we'll drag through over here. And now we've trimmed that to that cylindrical section. While we're still in this dialog, we can select extrude, and this allows us to just extrude while we're looking at the geometry. Now, this is one area where QuickSurface Pro has actually a pretty big benefit in my mind. If you turn on snapping, which is a pro feature, it'll actually let you snap to the mesh, and it'll give you that color bar analysis to tell you how close you are to the original shape. What you would need to do if you're using this in the light capacity is manually measure these features and make sure you understand how big or how tall this thing is. You can see here that we've had to go up roughly 140 millimeters and down about 11.5. I don't actually have this physical part because it's a sample part, so I don't know what the physical or real measurements would be, but in this case, we would just have to manually drag this up until we see it start to come through, and then we would have to use that as sort of our visual check. So now we've got this cylindrical section here, but there's something else that we should consider. We left the center solid, and this was intentional because we want to add the hole after the fact. The reason for this is because if we're trying to get the inside diameter from two mesh section sketches, they're never going to line up. So we want to make sure that we add the hole based on, again, measurements after the fact, and we're going to do that as its own sketch. So we're going to say, okay, and this is our first solid or primitive. Now, the problem that we may run into here is if we do another 2D sketch, we can't do this based off the top of this solid. We actually have to pull this plane up, or we need to have another primitive reference plane that we can use. In this case, I'm going to pull it up, select create, and then again, extract primitives. We're going to do a fit circle. I'm going to go around as much as I can on the outside here. We'll say okay. We're going to do a fit line, and I'm just going to zoom in, and we'll fit a line here. I'm going to hold down the shift key and zoom out, and then we'll grab over here and then let go of the shift key. We'll hit back, manually modify, and again, we're going to drag this out. I'm going to come over to this side and drag it out as well. Notice that if we pull it away, we actually do have the ability to get away from our mesh section sketch, but it does snap back to that mesh section sketch. So this is something to keep in mind, that we are still manually sketching here, but we do have the ability to do that. There is an option for auto sketch, but this is only available in the Pro version. So that's something to keep in mind, that we could do full parametric CAD and have tools like auto sketch inside of the full Pro version. But in the light version, we don't have that option. From here, we're going to select extrude again. Once again, I'm going to sort of go to the side view. This part here, I'm going to bring down past the top. And this section here, I'm going to bring down until it appears close. And I'm going to rotate it around. And again, I'm just going to drag it until it starts to get that sort of marbleized look, because I don't have a snap option in the light version. And then we can say OK. Now, one thing to keep in mind with this is I never trimmed the geometry here, so it gave me a full cylinder. If we want to go back and make any changes or edits to this, keep in mind that we do have a history down here. So if I right click and edit this sketch and use my trim tool, just come all the way through here, select OK. It automatically updated my solid for me because that was the only available profile. So there is a bit of history that is built into this program. So if you're using it as a parametric CAD program, you do have that in the bottom left-hand corner here. So that's a nice feature, especially if you have to go back and make changes, updates, or edits. One downside that we have to the light version here is tools like Combine don't work in the light version. It's only available in the pro version. We can still export all of these as individual bodies into another CAD system. So as long as we can create the geometry, we still have that option. But that's just something to keep in mind, that we can't actually combine these in here, but you can do it in the pro version. So what we're going to do now is we're going to create this reference slot over here, and we're also going to take care of the inside diameter. So for that, I want to hide these two solids. I want to bring back all of my planes, and then we want to go back to our main menu, 2D sketch, and we want to do a 2D sketch on a different plane. So we're going to select pick, and we want to select this plane right here. And then we want to pull it out until we get the cleanest possible reference. And as I mentioned, this is actually pretty deformed in here, so we're only going to get this to be so good. But this, once again, does give us the option to extract primitives. We're going to do a fit line over here. We're going to do a fit line over here. And we'll do a fit arc on this top section. Now, one problem that we are going to run into is that these are not going to come together perfectly. When they snap together, I'm going to use tangency, and I'll snap this one here and use tangency. But we are going to have to manually edit this by dragging it around and getting it as close as we can. So this line here, I'm going to drag all the way down. This one here, I'm going to drag down. And if we want to, what we can do is we can extract another primitive for a line at the bottom, or we can just use the line tool and connect them together here. And then we can select extrude. So once again, with the pro version, we can snap to the mesh. With this version, we don't have that ability. I'm going to leave this extruded beyond the outside as much as possible. And then I just need to drag it on the inside until it looks approximately right. So zoom in, and it looks to be approximately right. Now, keep in mind, once again, that with the light version, what we would want to do in reality is measure all of these features, because we don't actually have access to the geometry of the physical part that was scanned. So we're just kind of making some adjustments or kind of visualizing it without actually having those measurements. So next thing I want to do is, once again, another 2D sketch, and I want to grab this inside cylinder. We're going to create. We're going to extract a primitive. This time I'm going to do a circle. Just drag it around here. And we're going to go ahead and say back, and we're going to extrude that. So once again, I'm going to go to a side view, pull this all the way through the top, down to where I think the bottom is, and we'll select OK. So at this stage, we've got a couple of different solid bodies. This is going to be cut away, these two will be joined together, and this section will be cut away. So in order to turn this into the final model, again, in QuickSurface LITE, we don't have those tools available to us. Those are only available with the full CAD package in Pro. But we do have the ability to export all the solids. So what we're going to do is we're going to export this as a solid body. And I'm going to call this basic part, just YT for YouTube. And we have a couple of file options, and there are some differences here, some things that we want to make sure we understand. We do have a couple of file types for QuickSurface, like the QS NURBS. There are also some freeform options, so .obj. This will give us the control cage of a freeform surface that we create in here. But we're mainly focused on the step models or the IGES models for what we're doing here. Now, what I found with most of these step exports is it's going to place each specific body into its own component if we bring it into, say, Fusion. Or if we use the IGES option, it's going to make everything, every individual face, a surface. So you have to play around with which one of these is going to work best for you. I'm going to use the step for this version. I'm going to select Save. We're going to say OK. And now we're going to go ahead and go into Fusion and see what this looks like. All right, so opening this up in Fusion, you can see using the step file format, we've now got a component for each of these solid bodies. Once we start using things like combine to subtract or add them together, they'll start getting combined into their own components. But if you really want to, what you can do is drag the bodies to the top level, keeping in mind that they're all going to be named body 1. So you will likely want to change that. We're going to go ahead and drag this one up. I'm going to call this one body 3. You can, of course, name them what they actually are. So that would be the slot or the keyway. And I'm just going to call this one body 4 and drag that up. And then each of these can be removed or deleted. Now, keep in mind, we don't want to delete it with history on. So since I opened this up in Fusion after I uploaded it to the data panel, the timeline is on by default now since the recent update in Fusion. So if that is the case for you, you want to use remove, which puts a remove feature in the timeline rather than deleting it, which will also get rid of those original bodies. So the first thing that we want to do is select combine, and we're going to join this main body together, body 1 with body 2, and say OK. Now, before I do anything else, I want to note that this face doesn't match this face. And this is a potential problem that we have whenever we're reverse engineering parts. And that's simply based on the fact that the sketch that we get, the line that we created for this upper extrude, for example, it can be just a very small, minute amount off or different from this face here. One way that we can approach that in Fusion is by using delete. And I'm going to hit undo and select this face and hit delete. And you can see that sometimes what we end up getting is these errors. And this is because this is a very minimal face. But in reality, what we need to do is we need to get both of these faces to be on the same plane. In order to make this a little bit easier, what we can do is we can take this one and use press pull and bring it out to make it a bit more exaggerated. You can see now we've got this sort of extra face. And then we're going to use split body, bodies to split, and the splitting tool here, and allow us to get rid of that extra section by right-clicking and removing. So now everything's clean. A lot of times delete works pretty well, but on geometry where the difference is very minimal, sometimes it has problems and you may be better off using tools like press pull and then simply splitting the body or cutting it with one of the faces that you want to keep. Next, we've got this extra little keyway feature on the back. I'm going to do an individual cut feature. So we're going to remove that. And lastly, we've got the inside diameter, which we want to do as a single feature. And we're leaving this to the end. So that way we've got a clean cut on the inside. So now we've added all those features. And if the final part had small fillets on the corners, we would want to go ahead and add those now. Likely going to be pretty small or minor, but we could add those at any point in time in the design. Again, I don't have the physical design, so I don't really have a reference for what these features would have been. But in reality, most of the time, the edges on a machined part are going to be deburred, which means that they are going to be rounded off a little bit. So that way we can get those cleaned up. So that's going to be the final process. Again, QuickSurface LITE is going to have limitations for doing things like creating CAD geometry, using features like combine or cut, or even applying fillets to this geometry. It's only possible in the Pro version. But the QuickSurface LITE version does give us the ability to process the scan data. We can do some cleanup, some editing, some filling holes, reducing noise. We can gather primitives or extract primitives. Then we can use those to align to a coordinate system, and we can extrapolate and get 2D sketch data that allows us to build our parts out in 3D. And with the limitations of QuickSurface LITE, we would need to then export those primitive solids and combine them in our CAD software of choice, Fusion, SolidWorks, Inventor, whatever you're using. So there are some other tools that are available inside of our QuickSurface LITE, and I want to talk about them just briefly. They don't really apply to this part, but I do want to note that we do have some surfacing tools. And if you click on tools and it looks like everything is able to be created, for example, it can calculate a fit surface. If you click on a tool and it says this is only available in Pro, you'll know right away. But things like fit surface can be created. I'm going to go ahead and hide the fit surface. We also have some surfacing tools that we can use. They're going to be a little bit more limited than the fit surface. We also have auto freeform. And what this allows us to do is try to wrap a freeform model or freeform surface to our design. For a prismatic part like this, it doesn't really work. For something that's more organic in nature, where there is less of extruded cylinder or extruded box, then we can start to see some power from auto freeform. But for the most part, this is a nice way that we can just auto create geometry. And if I hide the mesh, you can see here that we do have a representation of the body. So if you want to create something quick based on the mesh, you can do that. We also have freeform tools, which allow us to begin creating a freeform model directly on the face of our mesh. Now, this is something that we do in Fusion, of course, but this does give us the option to start building this out in 3D by creating these sections of freeform models. Once again, not really something that we would do in this case on a prismatic part, but those are tools that are available for us to use in the LITE version that could be used on more organic parts that we may be scanning. It is important to play around with this. You can download a trial of QuickSurface LITE. And again, we were using the example basic part, but there are other examples in here that you can take a look at. There's a scanned impeller, for example. So what you could do is you could play around with using this model, which is already aligned to a coordinate system, and try some things like fitting a surface or using auto freeform to try to generate a model based on this. And then you can work backwards and try to do things like create a pattern of it in your CAD software of choice. Just make sure that you do take a look at some of these examples. Basic part, Lego block, these are good ones to play around with. There are also some more advanced ones. There's a machined part and a bearing housing, things like that, where you can really dive deeper in and see how much you can do in the LITE version versus the Pro version. Now, if you have any questions on this, please leave a comment and let me know. So we are going to be covering the QuickSurface Pro version as well as QuickSurface for SolidWorks, but we're going to be doing those as courses on our learneverythingaboutdesign.com website. So those will be for purchase. We're going to be covering the LITE version here on the YouTube channel, as this is most applicable to users that are using hobby scanners or are using tools like Fusion as opposed to SolidWorks, for example. But if you have any questions on that or QuickSurface LITE that you saw here, please leave a comment below. If you are looking to purchase QuickSurface LITE or any of the QuickSurface versions, we are an affiliate channel, so I'll leave all that information in the description below. So if you want to check that out, please make sure that you check out the description. As always, thanks for watching, and we'll see you in the next one.